plan is that we have an hour. I will see if I can fit everything in an hour. But basically, I want to go through the basics of Git and just reiterate stuff so you know what Git is, what it is used for. If we have any time left, I will go into some complex examples. And like Git is a very weird thing, and a very the learning curve is very steep. So you're gonna run into a lot of problems, and I ran into a lot of problems myself. So I'm gonna show a couple of examples of what that might look like, and then we can just chat and ask questions if you didn't understand something and so on. Cool. Okay, so before I even explain what Git is, let's go through this. So in my mind, the best way to think of Git is basically a time travel machine. Or if you played any video games where you can save on checkpoints, that's like a perfect example of Git. So each of these, you will see a lot these kind of graphs where you have branches and points. So we're clear, every point is basically your project at a particular point of time. Each transition between a point is any changes that you make. So for example, I could start with a simple HTML page in the first commit, and then I could go and add pagination and multiple CSS files and so on. And then I stack those commits, and that's how my project evolves. Sometimes, same way in sci-fi movies, you would get time branches, which is basically if you want to add something unrelated to the main thread, to the main branch, to the master branch, which is the common terminology for it, you would create a separate timeline and follow your timeline independent of whoever may work on the master branch. This is very, very cool to do just because of this kind of independence of anything else. If you would imagine not using Git or something like that, you would probably have 3 people working on the same file. You would get ridiculous file names with version 5, 2020, final, blah blah blah, all of those. If anyone saw those memes, if nobody uses, if people don't use version control systems, they get very ridiculous file names. And you would merge that all together when 3 people come up with 3 versions of the same file, and then you need to sit and merge that all. So Git solves a lot of those problems. Okay, so common terminology. Once again, each node is basically a commit. Commit is your checkpoint, your point in time with your project. The main branch is called the master branch, and your the place where you're currently, basically where you are in the project, is the head, your head. And every timeline is a branch. I don't think there's much more to explain here. So that's the gist of it. Git is your tool to time travel between your changes. If you have a year-long project, you can see what you've done half a year ago and your progress. And it's very easy to collaborate as well. So let's kind of see what a commit or a state, so a state of the Git structure looks like. So this picture right here represents one commit node. You have your working directory where you have, this is the place where you change your files and so on. You have your staging area. The staging area is it's rarely used. I've not seen a very common use case to keep a lot of files in your staging area, but this is a pre-commit state. So you're saying I will create a file, Then I'm going to add, with this command, git add the file to the staging area. And then when I'm like sure I have everything in place, I can commit that to my repository, to my local project. Right. Another term is that this whole thing, this whole tree structure is called a repository. And you will hear that in GitHub repositories, which are like remote repositories that are seen by everybody in the internet and so on. And it's also, you will hear a local repository. A local repository is just a copy of your work on your local machine. Hopefully that's going to become more clear as we go. And actually, why don't we just start a fresh project? I'm going to just show how that all looks like. So let's see. So I have already created a directory here, and I have opened it with VS Code. You can use whatever you want. You can use whatever editor you want. I just prefer, I just prefer VS Code just because it's easier for me to code in. Another point that I'm going to make is that Git installation is tricky. If you're using a Mac, it might be as easy as running like brew install Git. And if you don't know what brew is a package manager for Mac installations, command line tools, and so on. You should definitely get brew if you're using Mac. On Linux, I think it's something like sudo apt-get blah blah blah. And on Windows, you would need to install a separate Git bash utility for using Git. I'm not going to go through installations just to save time. If you already have Git, feel free to follow along. If not, just I guess it's going to be like television for you. Okay, well, let's go into it. So we have a fresh project. We don't have anything in it. I'm going to initialize a Git repository. Initializing a Git repository means that now this is going to be like, I'm declaring this as a Git repository. I don't know how to explain it more. Git init does that. We can see that it says initialize empty Git repository. And it also displays the path to this interesting file, which is not shown on the tree, but it is definitely present in our folder. So basically this folder .git is where all your Git configuration will happen. I'm going to show a lot of commands that will seem like magic, but this whole magic is happening in .git. This is where all your refs are stored. This is where all the information about all of your commits are stored. So, okay, let's do something simple. I'm going to create an index HTML file. And I'm going to do like a simple template. And let's say this is like Git workshop. Add like a title or something. Now this basically, like, this will be different for different OS systems. On Mac you can do open index.html. On Windows you can just double click index.html. Like, there's multiple different ways. Just to the point that this might not work on your OS. This basically opens the HTML in your browser. And perfect. Okay, so we got like a static HTML page. Now what? So remember I was talking about staging and commit states in here. So we can actually see that because hopefully we have like a VS Code tool to see that. If I do git add and dot means everything, and you can see that this is the command that you need to run to move all your changes to the staging area. If I run this, you can see that we have stage changes. Here's your index.html. Now, if I want to commit my changes, I can run git commit -m, and usually your first commit is just an initial commit. So if I'm going to do that, we can see that one file changed for routine insertions, everything went smooth. And what I like about VS Code is extensions and like how much stuff you can do with it. I'm going to use, I believe it's called Git tree, if I'm not mistaken. Git Graph. Git Graph allows you to like visually see your Git tree. And if I click here, you can see that we only have one commit, nothing too exciting. Let me do another change, another commit, so it will be a little bit clearer. So I'm going to do like a p tag, search, great, whatever. I'm gonna go through this workflow again. Git add everything, git commit, added description. Now it's a very good practice to like structure your commit messages in a certain way. Sometimes you would structure them like in a past tense. Also, people often do like this commit will, and you say this commit will add the description. Whatever works for you, just as long as you're consistent with it, and it makes sense to whoever is like reading your commit logs. Okay, so we have a second commit, and now if you look at the Git graph, we have two commits here. We have initial commits, and we have an added description. Now, what next? One neat thing, just a small tip, if you have like, if you edit a file that already exists and existed in your Git repository, for example, I can edit this and say like sub description. You don't need to type out git add dots and git commit -am every time. You can just squash that into commit -am. And like, I can say whatever here. So description. And that will work the same way. This only, however, works if you added a file that was already present in your Git repository. So yeah, this is just a quick way to commit stuff. So okay, great. So we have like 3 commits to work with. This little dot, like this not filled circle, shows your current position in the Git tree. And I can change that actually. So another cool thing I can do is say git checkout. I can specify a commit hash. So each commit, each node over here has a hash by which you can identify it. So hash meaning just a long string of numbers and letters, just an identifier basically. Yeah, so I can grab like a hash of a commit that I want to jump to. And actually, if you don't have this tool over here, a very cool way to see all your commits is Git Log. Git Log will show where your hat is. So my hat is at master, added subdescription, and we have like 3 commits here. And you can also grab like a hash from here. Yeah, so that's super useful. Also, I'm gonna just grab it here. So copy commit hash to clipboard. And I'm gonna git checkout this hash. You can see that the dots moved to a previous commit. And if we look at our index.html file, we basically went back in time where we did not have the subdescription. And now we're on the state where we only have like the description. Now, if you read through what Git is telling you, it's saying that you're in a detached head state. So you basically can look around, make experimental changes, blah, blah, blah. Usually you use this to just see what was there previously, or like, for example, you achieved a point in your project that is solid, then you added some changes, you want to revert back to that solid point to like show off your project maybe. So there's like multiple use cases for this, but basically this allows you to move between commits, move in time. Yeah, so to move back to my master, there's like 3 ways to do this. I can either say git checkout this hash, or I can say git checkout master, or a very easy way is also say git checkout minus, which basically says like move to whatever state was, whatever commit you were on before. And that will move me back on master, and you can see that the dot is back here. All right. Boom, boom, boom. That's great. So let's see. Okay. Before moving into GitHub, I want to show how branches work first. And that is also to the point of what I was showing before. So if you, for example, want to work on a feature right here, you could create a separate branch that is independent of master, and you could work on your feature on that branch and then merge the feature into the master branch. So let's see how that might look like. So let's do a scenario. Let's say there's 2 people working on the project, and let's say it's Alice and Bob. Alice continues to work on the master branch. She has a bunch of work to do, so she's going to just continue the master branch. And Bob has a specific task. He wants to implement a button. So let's say I'm Bob first. This will be like very weird to display, but bear with me. Okay, so if I'm Bob, I'm going to create a new branch. I'm going to add a button. So git checkout -b, and then you can specify your branch. So you can say feature and like awesome. This is just also like a structure of how you might name your branches. Anything can go here. You don't need to follow this like foo, bar, baz, whatever. You don't need to follow this structure if you don't want to. Just come up with whatever works for you. This is just commonly used across multiple repositories. I find it's easy to look through. Okay, so awesome button. Great. So even here, I don't know. Depends on once again what tool you're using. It might show you the current branch you're currently on, and I can see that I was on master before. Here I was like on random commit hash. Now I'm on feature awesome button branch, which is great because this means that I'm not longer impacting master. And in fact, if I add a button here, so let's just do that, button. I commit this. So add docs, git commit. You can also see like this turns yellow. It helps you identify how many files are in the staging area. So git commit, edit button. Cool. So now Git Graph will not help us much. It will just display this as one branch. And right now, this is because there is no difference between them. Like feature awesome button is just following up on master. So let's actually change something on master so we can actually see those be different. Git checkout. So git checkout is like your common tool for moving in between branches, moving in between commits. Git checkout master, and that moves me to master. And you can see that our button disappeared. That's because our button is on the feature awesome button branch. Now, let's say I'm Alice now, and I'm working on my master branch, and I want to add a new file. let's say it's like a readme .md, and I'm saying like this coolest projects ever. Great. So like I'm Alice, I can now git add dots, git added readme. And now if we look at the Git graph, you can clearly see the separation now. You can see that we have a commit on master, which is not present on the feature awesome button branch, and vice versa. Like feature awesome button has a commit that is not present on the master branch. That's why Git graph is separating them. So let's finish being Bob, I guess, and let's check out our feature awesome button back. So now we are on here, and I'm gonna just look how this looks like so far. I don't know if this is super exciting. I want like, I don't know, an inline style, something. I think like border, 3px, solid orange. That's how I feel today. Yeah, so now if you have a look at that, we have a gray border. You can also say like border radius. I'm going on a tangent here. I'm sorry about that. I just want to make this look cool. Okay, great. Now I can commit this. I can say git commit. I'll use the -am notation. We'll say that I styled create button. Cool. So now we have 2 commits on our. So this is a little bit weird. Now master became bank for whatever reason, but you still can see the separation between them. So we have 2 commits on awesome button and 1 commit to master. Let's just merge that in. So like you could, coming back to the time travel analogy, this is your main timeline. This is the timeline that Bob created. Now Bob wants to merge his timeline into the main stream of things. So to do that, we're gonna do a git merge. So I'm gonna check out back to master, and I'm gonna do git merge. And here you specify. This is very like hard to remember, but your git merge works this way. You need to be the branch you want to merge into, and then you specify git merge what branch you want to merge. So you say git branch feature awesome button, and here git just sees that like git is smart. It's gonna try to like merge, because you can imagine you're gonna have like multiple files in a bigger project, right? Like, and there's gonna be different. Like you added a function to one file and you like removed something from the other file. And Git is smart enough to like detect those changes and kind of smartly merge them together. So it creates like a separate commit for that. And this window is basically your editor representation of a commit. Every hash is a comment. Everything that is not a hash will be used as a commit message. So usually just leave it as merge branch, whatever. And this is Vim, which is great because I hope people know what Vim is. If not, have fun practicing. Yeah, so that's it. So we have now our awesome button merged into master. And you can see that this is like our commit that we just created, merge branch feature awesome button. Now if we have a look at index.html, we have our awesome button. We have the work that Alice did, which is the README. So our branches are basically merged in together. Cool. This should look the same. How are we doing on time? Okay, it's 11:30. I'm gonna quickly go through GitHub, probably. And then I'm actually gonna show 1 or 2 cool things that I think would be useful for everybody. Okay, this is all cool and great. Actually, before we move into, are there any questions so far? Okay. If for Mac 2 is helpful, yep. Okay, yeah. Feel free to drop anything or speak up. You can interrupt me at any point of time. So this is all cool and great. Like, we have our local repository, we can work on it together. But how do you actually like work from two computers? Because like this is your local setup on your local machine. For that, you're using a Git client, which the most popular one is GitHub. This is my GitHub page. I'm gonna go and create a new repository. So a repository is basically, as I was saying, it's your collection of all your commits, all your branches. And when you're creating a repository in GitHub, this is a repository on the cloud. So that will be stored somewhere on the internet. So I'm going to go and create a new repository. I'm going to make it private just because. Actually, I might make it public, so maybe you guys can try out some stuff. I'm going to make it private for now. So repository name will be like dsc git. I can provide the description, and okay. So here you have like multiple options. GitHub prompts you to add like a README file and a git ignore file, and choose license. These are cool things. The README, we already have one. We don't need that. Git ignore is a thing that is very cool to have because sometimes you don't want to include everything in your Git repository. I might talk a little bit about that later on, but for now, I just don't want to focus on this too much. Yeah, let's just create this empty repository. Here, you basically, like, GitHub tells you what to do. So we already did git init, git add readme, blah, blah, blah. So this is the step that we need to do in order to like connect our local repository to the remote one. This is kind of tricky because you will like right away it prompts you to like use HTTPS or SSH, and might be confusing what those are. There is a separate configuration for these options. Are basically like for you to specify in your project to reference the cloud repository. I'm going to use SSH because SSH is just set up on my computer. If you are wondering how to set up SSH, and by that I mean not to type out your username and password each time you commit, I can provide like a guide from GitHub after the workshop. But I'm going to just roll with this. So I'm going to copy this to my clipboard. I'm going to just say whatever GitHub is telling me. So git remote add origin. Let's do that. I'm going to explain what that means. So git remote. A remote is basically a link to an external repository. So this could be GitHub. There's also Bitbucket. There's multiple different clients for GitHub. And you can imagine that you could have like different remotes as well. Especially if you will go into like hosting your website and somewhere, you will also like have a separate remote to put your GitHub repository onto there. But I'm just going to add the GitHub one. So this is the syntax basically of the command to add the remote. So git add. This origin is just a naming standard. That's basically what usually people name this. This again could be like foobar, but this is whatever I want to name this. Origin, and I'm gonna paste my link in here. So this is my link to the repository. And nothing happened. That's great because hopefully that succeeded. And now git push -u origin master is what GitHub is telling me. I will do exactly that. Git push -u origin master. So -u flag is very useful if you want to track, like connect your branches between your local repository and your remote repository. This command will work as well. So like git push origin master is completely fine. However, if I do -u once, afterwards I could just say git push. So I don't need to specify which branch I want to push to, because basically what this command does, it says like push whatever branch you're on onto the remote that is named origin, and select the master branch from that remote. Hopefully that makes sense. If I specify this flag once again, I will not need to specify the address of the remote thing, because they are basically bound together and connected and all of that good stuff. So I'm going to do that. And this is great. So this is like telling us all the process. We can see that branch master set up to track remote branch master from origin. And that's exactly what I was talking about. So yeah, branch master, which is the local one, is now connected to the master from origin. Now if I update this, I hopefully will see my beautiful index HTML. README is a cool thing, because that is what was displayed on your GitHub projects page. So never disregard README and always provide descriptions for your projects. Yeah, so that's basically now my project is on GitHub. Anybody who wants can copy this SSH. If I obviously make this a public repository, they can either pull this down, clone this repository to their local setup, or they can fork and like work on their own repository. There's multiple ways there. I'm gonna talk like a couple of minutes about what these tabs mean. Quick tip, very cool setting that I quite like is the network tab over here. This is basically the same view that you would be getting here. I just like to see how my Git is structured like visually. This displays it pretty well, so you can see like this is the button that I added, and this is the master branch, and so on. So issues and pull requests are quite interesting things. So I'm gonna just run through this quickly. Let's say I'm right now on the master, and I want to, I don't know, let's say like add a link to something or like another feature. So ideally, if there's multiple people working on this, for example, Alice could create a new issue and say add a link to GitHub. Provide description here, and then she could assign people in the project. Right now there's only me here, but you could imagine that could be multiple people. Labels are quite useful, so you can like label your issues based on what they're targeting. Project is like another, basically your Kanban board, if you're familiar with that. I won't go into that, but that's definitely very, very helpful for like project management. I'm ready to submit my work. So I'm going to say git push -u to set the upstream and connect the two branches, so I don't need to connect them later. Origin is the name of the remote, and I'm going to say feature link to GitHub. Great, so now if I check GitHub, we hopefully can see that, yes, so GitHub prompts us to like automatically create a pull request. Also in here, you will be able to see like there's 2 branches in here right now. I'm gonna just do that, like assuming I'm Bob, I'm gonna compare in pull request. I say that I added a link. The link looks awesome. I can add reviewers, which also like could be different other people. This should probably be Alice since she created the issue. And also assignees, like I'm gonna assign myself. So this is my PR. I'm working on it, and all of the other stuff that I'm not gonna touch on, but it's definitely useful. Create pull request. Now back to being Alice. I'm going to check out the pull request. I see that somebody created this pull request. And actually, what I'm going to do before I'm switching personalities like super quick. So being Bob, I can also reference an issue. So this says like add a link to GitHub. So I'm going to say that this link looks awesome. Also solves number 1. So now Alice should probably get an update on her issue, since if we go in here, we can see that like I mentioned this issue in my pull request. Now if I'm Alice and I go into pull requests, I can review this. So I can see all the commits that were done. And the files that were changed, so I can see that this what my index.html looks before, this what I have added, and yeah, so like if that satisfies me, I can say review changes, approve. Well, yeah, because I'm probably I cannot approve my own pull request, but that's fine. So if you would imagine there would be 2 people, you would approve the pull request on that side. Yeah, and then I can just merge this pull request. So very important point is that like you need to look at what is specified here. So this is the branch that is the work was done on, and this is the branch that we're merging into. And you could imagine that this could be anything. That could be another branch, like a separate one. So it's very important to double check what you're merging into what before doing it, because you will need to do extra work to undo that. Yeah, but I'm going to just merge this. So for merge. Usually, like if the work is done on the branch, I don't need it anymore. I can just delete the branch. Now if we go into code and look in our commits, we have a bunch of commits. The latest one is merge pull request number 2, link to GitHub, and obviously we have index.html. Here's our stuff. So one thing, if I git checkout master in here, you'll notice that link is not here. That is because the branches are not automatically synced. You need to pull your changes from GitHub. So git pull is a command to do that. You can say pull origin master. Yeah. Oh shit! I should have probably done git pull just so I could not specify like origin master because I've done git push -u, but that's fine. We can see that the link is here and we are up to date with our remote repository. That about concludes GitHub and its core. Like you can then go into issues and obviously close the issue because it's been dealt with. Yeah, that should be enough for you to go onto GitHub, create a repository, and work on that repository with your friends. No more zip files and like files floating around. This is the way that people do things in development, I guess. 46, I'm gonna show one thing, which like I have multiple here. I'll probably, like, if people are interested, I will break off into another talk workshop and show more complex stuff with Git. I'm gonna show one cool thing that is like very common to do in Git, and that's when you fuck up your commit messages. Basically, yeah, I think that's gonna be fine. So let's say, so I'm on master. We're gonna say git. Let's make a change, and let's say that something here. Don't really care. A change. Totally change. Git commit -am and made a change. So I'm gonna like typo by not by accident. And actually, the point is, like, this is a common thing that could go wrong, and this is a common use case. Like, if you notice that your last commit is different, you want to change the commit message, you can say like git. So I can maybe change this again. I can say git commit. Let's say add dot commit. I can say -- amend. So what -- amend does is it says, don't commit this as a new commit. However, modify whichever commit was before that. So made a change doesn't look right, so I'm gonna amend that commit, and it will prompt me to also change the message. So I'm gonna edit this. Change. And that's great. So like now you can see that I did not add a new commit, but my previous commit got changed, and my my commit message is up to date now, and everything is cool. If you don't want to change the commit message, you just want to, for example, like you forgot to make another change that you want to like merge with the previous commit. You can say like make another change. And let's say I don't want to edit the message here. I can say git commit -- amend. And I believe it's like -- no edit here. Yeah, so this will not prompt me to change the commit message. It will just silently include these changes into the previous commit. So it's quite neat. That is definitely a common thing. 1150, I want to show how to resolve conflicts while merging. Let's just go for it. I hope it's not gonna take too long. So we've created 3 branches here, and we had some points where we were merging them together. You will most probably get into situations when your main timeline conflicts with your branch timeline. I'm going to demonstrate that. So I'm going to create a new branch again. So check out, I'm going to just say past branch. Oops. switch to a new branch. I'm gonna change my button name to my amazing button. I'm gonna commit this. Git commit. So typing this all in the editor is great and all. Usually, if you're in you can find like a local Git client in VS Code. You can also provide a message in here, and like commits everything with this. Whatever works for you. I'm just showing command line tool because they are common and they will work on everywhere, whatever editor you're using and so on. Okay, so git m changed button name. Okay. Now let's see. I will go back to my master branch. Check out master. You can see that stuff is in the old ways now. I'm gonna change this to like something completely different, like a completely different button name. I'm gonna commit this. Commit -am changed button name, like on master. Cool. So now if I try to merge my task branch into my master branch, let's see what's happened. So git merge task branch. And I got a conflict. So this like you can see that Git tried to auto merge index HTML, and it said like I failed. I could not merge this because like you need to decide what you want to go with. And this is a feature of VS Code and probably all major editors. You will get like this preview of what changes I'm like already in the head in the master, and what changes are incoming from the branch you're merging. So this was a completely different button name. This is what we had on master, and my amazing button is what we had on task branch. Here you need to decide for yourself what you need to keep or what you want to discard. VS Code provides you multiple options in here. So like accept current change will keep this one, accept incoming change will keep this one, and so on. If you don't have this kind of ID, you will probably just get these symbols. These are actual symbols in your ID, in your text editor, and you will need to like go through your files and manually do this. And I just find this very convenient. I can say, let's say I want to keep my amazing button, so I'm gonna say accept incoming change. This will delete the one that was on top and only keep my amazing buttons here. So, whoops. Once again, this like Git failed to merge automatically, so it's gonna create a separate commit for this. I'm gonna commit this. So I'm gonna say git commit -am decided button name. Cool. So now you can see that in Git Graph, we had our task branch, we changed something on the master, we got a conflict because something went wrong and either Bob or Alice did something that they did not agree on. They came back in and they resolved all the conflicts together, and everything is cool and green. 11:56. I'm gonna wrap up on this. I think I covered the majority of the stuff of the basics I wanted. Yeah, I will leave this presentation. I'll probably add some links to some Git cheat sheets, and all of that good stuff. So I like included some common commands in here. If you have any questions, you want more resources, feel free to reach out to me on Discord. Otherwise, thank you for listening.